10 amazing facts about the mind-blowing physics behind black holes. Hello and welcome to another episode of Knowledge Unlimited. If you enjoy the weekly episodes of this show, please remember to subscribe. Black holes are among the most mind-blowing things in existence in the known universe. Black holes and their physical properties have pushed the envelope for modern physics over the last 100 or so years. The theory of general relativity predicts that a sufficiently compact mass can deform the space-time to form a black hole. That's pretty cool, but let's look at some facts to figure out how they work. Fact 1. A black hole isn't a hole at all. In fact, it's the opposite. A black hole is a region in space where a large amount of mass is packed very tightly together. The label black hole comes from the fact that it has gathered so much mass and thus gravity that nothing, not even light, can escape it. Fact 2. Black holes are corpses of dead stars. Albert Einstein was the first to indicate that our universe contains such unusual, dense, enormous objects in his general theory of relativity, published in 1915. As a natural result of huge stars dying and collapsing, black holes originate from Einstein's equations of general relativity. Karl Schwarzschild, a German scientist and astronomer, suggested the contemporary concept of a black hole in 1915, after finding a perfect solution to Einstein's general relativity approximations. Schwarzschild realized that mass might be compressed to an endlessly tiny point. Nothing would be able to escape its curvature as a result of this. The most well-known mechanism for a black hole to develop is through star death. If the total mass of the star is large enough, about 3 times the mass of the Sun, it can be proven theoretically that no force can keep the star from collapsing under the influence of gravity. Megastars explode in tremendous explosions known as supernovae as they reach the end of their lives. A burst like this sends star matter into space but leaves the luminous core behind. Nuclear fusion provided a continual outward push that countered the inward pull of gravity from the star's own mass while it was alive. However, there are no longer any forces opposing gravity in the stellar remnants of a supernova. Thus, the star core collapses in on itself. A black hole is formed when its mass collapses into an infinitely small point. All of that stuff, many times the mass of our own Sun, packed into such a small space, gives black holes their tremendous gravitational pull. Fact 3. Black holes eat and grow from matter coming too close to its gravitational pull. Black holes can grow to any size they want throughout their lives, slurping gas and dust from any objects that get too close. Due to a dramatic increase in the intensity of gravity as objects plummet into the black hole, anything that reaches the event horizon, the point at which escape becomes unthinkable, is in theory destined for spaghettification. A black hole's event horizon is the border that surrounds the black hole's entrance and even beyond, which light cannot escape. A particle cannot exit after it has crossed the event horizon. Over the event horizon, gravity remains constant. Fact 4. Normal physics does not apply inside a black hole. Physics gets berserk inside the event horizon. Calculations indicate that the appearance of the fabric of space-time within a black hole is determined by the black hole's history. It might be tumultuous, twisted, or any number of other things. But one thing is certain, the tidal pressures would destroy anything. There is something called singularity within a black hole, according to theory. All of the stuff in a black hole is squashed into a singularity. It is described as a point of infinite density in the heart of the black hole. But that is likely incorrect. Granted, that is what classical physics tells us is there, but the singularity is also where conventional physics fails, so we shouldn't trust what it says here. If you happen to fly near a black hole, its extreme gravitational pull would increasingly slow down time and warp space. You'd be tugged ever closer, gradually joining an accretion disk of orbiting space material, stars, gases, dust, planets, spiraling inward toward the event horizon or point of no return. Once you crossed this boundary, gravity would overcome all chances of escape and you'd be super stretched or spaghettified as you plunged toward the singularity at the black hole's center. An inconceivably small point with a monstrous mass where gravity and density theoretically approach infinity and space-time curves infinitely. In other words, you'd be gobbled up and annihilated in a place that utterly defies the laws of physics as we understand them. Fact 5. Black holes come in stellar, intermediate, and supermassive sizes. The first type of black hole is known as a stellar mass black hole. These are the remnants of massive stars. When a star with more than 5 times the mass of our Sun bursts as a supernova at the conclusion of its life, gravity compresses its core quickly and violently. Depending on the mass of the star, the collapse may come to a standstill, becoming a neutron star. However, if the core's mass is adequate, it will continue to collapse, becoming a black hole. The masses of stellar mass black holes range from around 5 times the mass of our Sun to about 60 times the mass of our Sun. They usually have a diameter of 15 kilometers to 50 kilometers. The supermassive black hole is another form of black hole. These can be billions of suns in mass. Most galaxies, according to astronomers, have supermassive black holes at their centers. Sagittarius A, the black hole in the heart of our own Milky Way, has 4 million times the mass of our Sun and is 60 million kilometers in diameter. Although the exact genesis of supermassive black holes is unknown, they are thought to have evolved in the early history of the cosmos from gigantic collapsing clouds of interstellar hydrogen. They may have also gathered more mass by mergers with other black holes throughout the ages. In 2021, scientists revealed the findings of a black hole of intermediate mass. This form of black hole spans the gap between stellar mass black holes and supermassive black holes found at galaxies' centers. The Goldilocks black hole, which was just found, has a mass of 55,000 suns. The researchers discovered the intermediary black hole by detecting something far behind it: gamma-ray burst emissions. Fact 6. Supermassive black holes also give birth to stars and determine how many stars a galaxy gets. In the same way that planet-sized fragments are expelled from the accretion disk, a recent discovery shows that behemoth black holes occasionally unloose enough material to form whole new stars. Even more remarkable, some even land in deep space, well beyond their galaxy of origin. And a 2018 study in the journal Nature suggests that supermassive black holes not only create new stars, they control how many stars a galaxy gets by directly impacting how quickly the process of star formation turns off. Star formation, perhaps strangely, stops more quickly in galaxies with smaller, in a manner of speaking, black holes at the center. Fact 7. Black holes are the ultimate energy factories. Black holes can generate energy more efficiently than our Sun. The way this works has to do with the disk of material that orbits around a black hole. The material that is nearest to the fringe of the event horizon on the inner edge of the disk will orbit much more quickly than material at the very outer edge of the disk. This is because the gravitational pull is stronger near the event horizon. Because the material is orbiting and moving so rapidly, it heats up to billions of degrees Fahrenheit, which has the ability to transform mass from the material into energy in a form called black body radiation. To compare, nuclear fusion converts about 0.7% of mass into energy. The condition around a black hole converts 10% of mass into energy. That's a big difference. Scientists have even proposed that this kind of energy could be used to power black hole starships of the future. Fact 8. There is a supermassive black hole at the center of our galaxy. Scientists believe there is a supermassive black hole at the center of nearly every galaxy, including our own. These black holes actually anchor galaxies, holding them together in the space. The black hole at the center of the Milky Way, Sagittarius A, is more than 4 million times more massive than our Sun. Although the black hole, which is almost 30,000 light-years away, is pretty dormant at the moment, scientists believe that 2 million years ago it erupted in an explosion that may have even been visible from Earth. Fact 9. Black holes slow down time. To understand why, think back on the twin experiment that is often used to explain how time and space work together in Einstein's theory of general relativity. One twin stays on Earth while the other one zooms out into space at the speed of light, turns around, and returns home. The twin that traveled through space is significantly younger because the faster you move, the slower time passes for you. As you reach the event horizon, you are moving at such high speeds due to the strong gravitational force from the black hole that time will slow down. Fact 10. Anything can, in theory, become a black hole. The only difference between a black hole and our sun is that the center of a black hole is made of extremely dense material, which gives the black hole a strong gravitational field. It's that gravitational field that can trap everything, including light, which is why we can't see black holes. You could theoretically turn anything into a black hole. If you shrunk our sun down to a size of only 3.7 miles, 6 kilometers across, for example, then you would have compressed all of the mass in our sun down to an incredibly small space, making it extremely dense and also making a black hole. You could apply the same theory to Earth or to your own body, but in reality, we only know of one way that can produce a black hole: the gravitational collapse of an extremely massive star that's 20 to 30 times more massive than our sun. Thank you for watching this episode of Knowledge Unlimited. If you enjoyed the show, remember to subscribe before you move on to another YouTube video.